Tired of waiting forever for your machine learning models to finish training? With GPU accelerated machine learning, you can train a millions of records at lightning speed, and more importantly, without making edits to your existing code. In this video, I'll show you how GPU supercharges machine learning on large datasets using NVIDIA cuML. And with just one single magic command for acceleration and two magic commands for profiling added, you'll not only speed up your pipeline, but also monitor your GPU's performance along the way. Let's jump in. Some machine learning algorithms can be computationally expensive and painfully slow. On a dataset with just 1 million rows, models like support vector machines can take hours to finish. For developers, it's a serious bottleneck to productivity. Speed isn't optional anymore, it's essential. With cuML's zero-code change interface, you can take your existing scikit-learn or UMAC code and run it on the GPU. No new API required. This instantly reduces execution time from hours to minutes and supercharges your machine learning pipeline. You might be wondering how to install the latest cuML package. It's simple. Just head over to the cuML download page. The link is in the description. Select your preferred release, installation method, system CUDA version, and the cuML package. Then copy and paste the command into your terminal or in a Jupyter notebook cell. And you'll have the latest version ready to go. Next, I'll walk you through the machine learning pipeline with a real-world use case and show you the code in action. You can try the notebook on Google Colab or Kaggle Notebook. The link of the notebook is in the description. The Forest CoverType dataset is a popular real-world dataset. It includes a variety of physical and ecological features from the Roosevelt National Forest. The goal? Predicting the forest cover type, labeled from 1 to 7, with each number representing a different type of forest cover. For this video, I'm only covering random forest algorithms, but the notebook covers other algorithms such as logistic regression and KNN. As I mentioned earlier, typing into GPU acceleration is super easy. Just add a magic command at the top of your notebook and your algorithms will run on the GPU. The best part? The rest of your machine learning imports remain unchanged, assuming you are using scikit-learn. No code rewrites needed. Next comes the familiar machine learning pipeline, splitting the data into train and test steps, normalizing the features, and then fitting the model and making predictions. Now that we've set up the pipeline, the next step is to find the best hyperparameters for our model. We'll use GridSearchCV to find the best hyperparameters for our model. We define a parameter grid, run the search on the training data, and then check the accuracy of the test set. With GPU acceleration, this process is much faster than running on a CPU. You might be wondering, how do I see what my GPU is doing behind the scenes? With cuML providing magic command, you can monitor every function call and track exactly how much work is happening on the GPU. With cuML profile magic command, it profiles GPU versus CPU usage for the functions you run inside the cell. It tracks how much time each function call spends on the GPU or CPU, and how many times those calls happen. This lets you verify that your ML pipeline is being accelerated by the GPU rather than falling back to the CPU. And with cuML line profile magic command, it profiles each line of code in your cell. For every line, it reports how many times the line was executed, how long it took to run, the percentage of execution time spent on the GPU versus CPU, and the actual line of code. To summarize, we showcased how to accelerate machine learning models on GPUs with cuML, how to boost accuracy with GridSearchCV, and how to monitor GPU performance along the way with cuML Profiler, all without changing your existing code. And best of all, with end-to-end acceleration, developers can cut pipeline runtimes on production from hours down to minutes. I'm Allison Ding, developer advocate of data science from NVIDIA. I'd encourage you to try GPU accelerated machine learning with cuML today.